Hello. Hello. Am I audible to all of you? Hello. Hello. Am I audible to all of you?
Yes, sir.
Okay. And I think my computer screen is also visible to all of you. Okay. So good afternoon, everyone. So today we will going to perform. So today we will going to perform our next experiment in the measurement lab, and that is measurement of capacitance. Okay. So today we will going to perform the measurement of capacitance by the Wien bridge. Okay. Measurement of capacitance by the Wien bridge. First of all, we are going to first of all we will first discuss about the theory part, and then we will going to perform this experiment on the virtual lab. Is that clear? Hello. So first of all, we will going to discuss about the theory part, so that we can know what we are going to do. Okay. So for that, I just open my slides. Okay. So we will going to discuss about the theory part of the Wien bridge. Okay. So you can see that it is used. Wien bridge we are basically used in the to find the capacitance. Okay. So when we need to find the capacitance, then we are using the this Wien bridge. Okay. Uh, and it is a nothing but you know that it is the AC bridge. Okay. So if we replace the component, you can clearly see it is the first bridge, and in the first bridge you can clearly see that four arm is there, and AB, BC, CD, and AD. So four arm is there, and if we replace the component, if we replace this component of the of the of the this resistance and capacitance, then our Wien bridge is look like that. Okay, and here you can see that in the forearm of the Wien bridge, we are replacing, we are adding the four resistances there, and also two capacitance are there. And in between this resistance and capacitance, these R2 and C2 are unknown. Okay, this is the Wien bridge. Okay, and in the Wien bridge, you can clearly see we adding the four resistances there: R1, R2, R3, and R4, and two capacitances there. But here C1 and C1 is known. All the components are known except R2 and C2. We must find out these two value from the given uh, given bridge. Okay, so we assume that all the resistance are non-reactive. It is we assume that, and if we compare both the bridges, then we found that if we compare both the bridges, you can in the screen you can clearly see two bridges are there. If we compare both the bridges, then we can say that Z1 equal to this AB. If we compare these two bridges, then we can clearly say that Z1 equal to R1 plus 1 by J omega C1. We can write in that way, yes or no? Z1 equal to R1 plus we can write the capacitance in form of 1 by J omega C1. Similarly, Z2. Where is Z2? In the AD arm, Z2 is there, and we can if we compare the both the bridges, that we can write that Z2 is equal to R2 plus 1 by j omega C2. R2 is as it is, and we can write C2 equal to 1 by j omega C2. Similarly, the Z3 equal to R3 we can write, and also Z4 equal to R4. So this all by the comparing of the two bridges, uh, we can write these four equations. Is that clear? Okay. After that, after comparing these two bridges, we can conclude these four equations: Z1, Z2, Z3, and Z4. Okay, this four equation is there, and after that we can tell that Z1 and Z4 equal to Z2 multiplying Z3. We can tell that thing, and we just put the value of Z1 and Z4 here, and Z2 and Z3 here. If we put the value of Z1, Z4, and Z2, Z3, then what happens? Then we can see that we just putting the value here, and after that, if we uh, if we simplify this, then we can find out by the simplified this thing, we can conclude that two equation is there. After simplified the whole equation Z1, after simplified the Z1, Z4, and Z2, Z3, we can find out these two equations. R1 equal to R2, R3 by R4. That is the real part. If we distinguish between real part and imaginary part, here real part is there, and also if we compare the imaginary parts, then we can find out the equation number 2, that is C1 equal to C2 into R4 by R3. Okay, so by the comparing to both the bridges, we can conclude that two equation, we can find out these two equations. Is that clear? Till now, if you have any doubt, you can tell me. We just comparing both the bridges. Okay, and after that, we are comparing the real part and imaginary part. Okay, so this equation 1 and 2 are in the bridge. We can find out these are in the bridge in the balance condition. Okay, and these condition are satisfied by the successive adjustment of the C2 and R2. Okay, so this equation 1 and 2 are bridge balance condition, and this condition are satisfied by the successive adjustment of the C2 and R2. Okay, and when the bridge is in the balance condition, then the null detector show the zero or near the zero reading. What is the meaning of that? हम लोग जब ये जो ब्रिज तुम लोग देख पा रहे हो, इस ब्रिज में जब ये देखो बहुत चार रेजिस्टेंस और दो कैपेसिटेंस माने इसमें इसमें इंसर्ट किया गया है इसका 4 आर्म में। जब हम लोग इसमें दो चीज वेरिएबल रहता है, मान लो कोई एक रेजिस्टेंस और कोई एक कैपेसिटेंस का वैल्यू हम लोग वेरी कर सकते हैं। कोई एक रेजिस्टेंस और कैपेसिटेंस का वैल्यू हम लोग क्या कर सकते हैं? वेरी कर सकते हैं। तो वेरी करके हम लोग का एम क्या है? आवर एम इज टू नथिंग बट टू बैलेंस द ब्रिज। टू बैलेंस द ब्रिज, हम लोग को ब्रिज को बैलेंस करना होगा। जब ये ब्रिज बैलेंस हो जाएगा, जब ये ब्रिज बैलेंस हो जाएगा, बैलेंस को नियर बैलेंस कंडीशन और नियर टू बैलेंस कंडीशन में आ जाएगा, तब क्या होगा? तब ये डी इज द नथिंग बट नल डिटेक्टर। इट इज द डी इज द नल डिटेक्टर। तो अगर ये ब्रिज अगर बैलेंस कंडीशन में आ जाएगा, तो नल डिटेक्टर में वैल्यू कितना शो करेगा? 0 और नियर टू 0 शो करेगा। हम लोग का एम है ब्रिज को बैलेंस कंडीशन में लाना। बैलेंस कंडीशन में कैसे लाएंगे? पहले तो हम लोग C2 में, ये जो C2 तुम लोग देख पा रहे हो आर्म ए एंड बी में, इस C2 में हम लोग जो अननोन कैपेसिटेंस का वैल्यू मेजर करना चाहेंगे, उस अननोन कैपेसिटेंस को इस C2 में हम लोग कनेक्ट करेंगे। C2 का टर्मिनल में हम लोग उसका वैल्यू माने